Let's look at the first problem on slide 11. So we have a 5 kilogram block sitting 10 meters above the earth. It is then going to fall to the ground. And what we want to know is, what is the velocity at this point? Okay, we have to start by looking at before. So we know that in these scenarios, energy is always conserved. That means that the total energy before is equal to the total energy after. Okay, and the two types of energy that we are looking at are kinetic energy and potential energy. So we need to ask ourselves in these problems, what kind of energy do we have? So when it's just sitting here, we only have potential energy. It's not moving, so it's all potential. So we're going to use our equation for potential energy, which is mass times gravity times height. Our mass in this case is 5 kilograms. The gravity is 9.8 meters per second squared. And the height is 10 meters. When we multiply all of that together, we get 490 joules. So we know that before this thing fell, it had 490 joules of energy. Well, where did all of that energy go? It went into our kinetic energy. Right here at the end, we're going to assume that this is like right when it touches the ground. So there's no height at all. So there's no potential energy. It's just kinetic energy, which we know is 1/2 mv squared. And we know that all of this energy here went into this. So we're going to set our kinetic energy as 490 joules times 1/2. We know our mass is 5, and then we're looking for velocity. So we're going to multiply these together and divide. And we end up with 196 equals v squared. Take the square root of both sides, and you end up with a velocity of 14 meters per second.